Good morning, Ashley. So far, it's just me and you. I don't know what's going on.
Good morning. Um, oh, weird.
I know. I don't know what's up, but whatever. They'll be here, I'm sure.
Probably. Jen Day messaged me. She wanted me to let you know that she had to do something with her mom for a family emergency, but I don't know if she messaged you or not on Canvas.
I don't think I saw one. Let me check. No, I didn't. But thanks for letting me know.
Yeah, I don't know why she doesn't personally message you, but she texted me this morning.
Sometimes she does later. I don't know. Maybe she doesn't have access to it, or I don't know.
Oh, maybe.
I'm not sure.
Yeah, she messaged me at like 7 a.m. So I was like passed out. So
you were like, "Good morning." Right?
Yeah, I was like, wait, what? But yeah. Is it true that if you miss like 3 or 4 classes, you get dropped from the class?
It's 4 total. Yeah.
Okay.
But I mean, sometimes people have extenuating circumstances and then I allow it. You know what I mean?
Okay. Yeah. Okay. That makes sense.
Good morning, Amanda and Olivia. Yeah, we're so close to being done. I don't want to lose anyone,
Good morning.
Good morning. Happy Tuesday. I feel like maybe if I say it, it'll work, right? I had a dream the other day that I was getting more teeth. How weird is that? And I was talking to my sister about it, and I'm like, why am I having this bizarre dream? And she's like, well, I heard that if you dream all your teeth are falling out, you're super insecure. And so you must be super confident because you're getting extra teeth. Is that so weird? Why would I be having a dream? Here's what I think it was. I think it was, okay, so we have someone named John C that I'm letting in. I don't know who that is. Let's see what happens. So I think it was because, oh, they left. So there you go. I think it was because I have some new nieces and nephews that are all getting teeth right now. So I think maybe I was dreaming I was a baby again and getting more teeth, but I wasn't because I had all these teeth and then I was getting extra. Do you guys have weird dreams like that? Amanda's like, no. Nope, I don't. Do you guys remember your dreams?
I always have pretty crazy dreams, and I usually remember them a lot of the time.
Yeah. I'm not a great sleeper, I would say. So, hi, Yesenia. Okay, so today we're going to do more problems from PF7, and they get a tiny bit more complicated. Okay, so you have to really think them through. So we're going to do some examples of them. So when you get to the later parts of your PF7 homework, you don't get lost. Okay, but first, while we're waiting, anyone have a new shirt to share? Olivia, I feel like your shirt was shareable. Uh-oh, you're muted, but you're not muted. I don't know what's happening. There you go.
I have on a Freddie Mercury shirt.
Nice. Love it. Okay, anyone else have a shirt to share? I have a new one. It's not math, but it's close. so I think it counts. Okay, are you ready? Do you know the Muppets? He was my favorite, Beaker. So, because science. Isn't that fun? So, I love fun shirts. It does make people look at you a little weird, though. I have a friend who wouldn't let her kid wear any shirts like this, like when they were little. Thanks, Amanda, for that face, because I think that's like some sort of punishment. That was like my kid's favorite thing, to wear some character shirt that they loved. Yeah. All right. Malachi, I can't see you, but I think your video's on. Like, I'm not sure why it's like extra purpley or something. It's weird. Good morning, Valerie. Okay, any other shirts people want to share? Do you guys like to buy weird shirts? It's one of my favorite things to do. A little weird. All right, so today, new handout. I'm going to put it in the chat. I'm pretty sure that's the right one. It should say PF7 Day 2, examples, and you try. I'm hoping that's it. And I'm going to put mine on the screen so then you can see what the first one looks like. Oh, there it is. Okay. All right. So did anyone go through those PF7 last night and notice it was you were doing okay or you were getting stuck? Anyone have any problems, issues? I just got a weird update on my screen and it's like update now, update later. I'm like, oh my gosh, not right now. Did you ever hit the wrong button on accident and you say update now, even though you meant to say update later? Yeah, I do that all the time. Okay, so we're still in annuities. You should still have these formulas. Does anybody need links to any of the formulas or the TVM solver? You got them all bookmarked now. You okay? Has anyone thought about their final exam project and what they're doing? Anyone have an idea yet? No. Okay, make sure you come up with some ideas before Thursday, okay? Because that's what we're going to be working on. All right. So sometimes you're going to have problems that are two-step problems. So it says something happens and then something else happens. So you have to use two different things. So, and I think it's easiest in the TVM solver. You could do it on the formulas, but I think it's easier on the TVM solver. And the reason is if you do it in the two-step with the TVM solver, you first find the future value, then you move that future value to the present value, and you find a new future value. If you use the formulas, you use the annuity formula first, then you use the compound interest formula. So that's why I think that's a little bit more challenging, but we'll do it both ways so you can see it. So here's the first problem. You invest $140 a month for 6 years into an account earning 7% compounded monthly. After 6 years, you leave the money without making any additional deposits in the account for another 26 years. How much will you have in the end? So do you see how two different things are happening, right? For 6 years, we make these payments. That's why we're going to use the annuity formula if you're using the formulas. Then after 6 years, we don't do anything else. We just wait around and see how much money we have. Okay. So let's do this. Let me move to the worksheet. So how many of you like the formulas? Anyone in here using the formulas? Just Olivia? How many of you like the TVM solver? All right, I don't care. It doesn't matter to me. So if we look at the formulas first, just so we know which formula we would use. So for this first part where it says invest 140 a month for 6 years, 7% compounded monthly. When we're at that part, I'll ask Olivia, since she's the one who likes the formulas the best, which formula would we use? Would we use the future value formula, the payment formula, or the present value formula?
Would it be the future value?
You got it, because it just wants us to know how much we have in 6 years. That's where we have to start, part 1. So we're going to use that formula that says future value equals payment times 1 plus r over n to the n times t minus 1. I don't know why I keep writing those square brackets. I'm not a fan of them. Divided by r over n. So if you're using the formulas, that's what you would use. If you're using the TVM solver, you need to fill in all these blanks. All right, so this is the work you should be showing on your paper. Okay, so I want everybody, whether you use the formula or you use the TVM solver, to figure out our future value for just part 1. Okay, just part 1. How much do we have after 6 years? That's it. Just how much do we have after 6 years? When you have your answer, put it in the chat directly to me. Try not to ruin it for everyone. And we always round to the nearest cent when we're doing money. Okay, don't forget to send me it if you have the answer. I have one answer so far, just to part 1. Or if you have a question, like you don't know which blank to put things in. Okay, so far I have 2 answers. I have a couple questions too, which is fine. So I answered those. Anyone need help? Oh, I have another answer that's right. I have another right answer. All right, so on the formula, when you're putting it in the formula, what would you put for payment?
$140.
Yeah, 140 times, and then 1 plus. Our rate is 7%, so we're going to put 0.07. What's N in our formula? Malachi, what's N?
6 years.
That would be T. N is the number of compounds in a year.
Oh yeah. 12.
There you go. So it'd be 12. And then we're going to do 12 times 6 in our exponent there. And then we'll do 0.07 divided by 12. So that's what it would look like in our formula. In our TVM solver, N has to be something different. What did you put in for N in the TVM?
It would be 6 times 12, so 72.
Very nice. 72, then this is 7. We have nothing in our account to start with. We put in 140 a month, so I put in negative 140. Future value is what we're looking for. This is the one we're solving for. And then PY and CY are 12. Now, whether you do it with the formula or the TVM solver, you should get the same answer. And the answer that you should get would be $12,482.53. Did you get that? Those of you that I didn't get an answer from, did you get that? Yeah? Malachi, did that help?
Yeah.
Okay. So, and Valerie was trying it on both and got a different answer for her formula than she got with her TVM solver. But after we looked at it, then she figured out what she did wrong. So that's great. Use whatever is getting you the correct answer. So now for part 2, it says, okay, after 6 years, you leave the money. Well, what money are you leaving? You're leaving this money, okay, in the account, and you're not putting any more money in it. So no more payments, okay? But you leave it in there for 26 years. So if you use the TVM solver, you're going to say N is 26 times 12, which is, I don't know what 26 times 12 is. 312. Then I is still 7. PV is now this amount, so $12,482.53. Okay, and then payment is 0. FV is what we're looking for again. And then PY and CY are both 12. So, but if you use the formula, you have to do something different. You can't just use the annuity formula because it's no longer annuity. Why isn't it an annuity anymore? Why does it change?
Is it because you're not making payments anymore?
It is. We're no longer making payments. So then you have to go back to our compound interest formulas which is PF5. Do you remember PF5? So you'd have to go back to those formulas and use just the formula for compound interest, which would be, so compound interest formula is A equals P times 1 plus R over N to the N times T power. So you would put that $12,482.53 times 1 plus 0.07 over 12 to the 12 times 26 power. And you should get the same answer regardless of which one you use, okay? But you have to be careful and realize that you can't use the annuity formula. So you have to switch formulas. But you will have, Olivia, I know you like the formulas. You will have one piece of paper that has all the formulas on it. Okay, so it won't be all these separate pieces. Okay, and I can find that, put that in the chat right now too. So the only thing we haven't covered is, well, we haven't really covered payout annuities, but I think I gave you that on the formula sheet anyway. And then loans. So loans is the last things we haven't done yet. So I'll put the whole formula sheet in the chat for you, especially because you might need it if you're working ahead. Okay, so after you do this, what do you get with either the compound interest formula or the TVM solver? And a couple of you already sent me, maybe just one of you already sent me the answer.
This is the answer for the second part?
Yeah, you already sent it to me, Aaron.
Yeah. 76,000 or yeah, $76,634.11.
Very nice. And Valerie just put it to me in the chat. So great job. $76,634.11. That's nice, right? Why is it so big? It's because you left it in there, right? You left it in there for 26 years. Okay. Questions on that? Did you see part 1 and part 2? And anyone having trouble with their calculators getting the right answer? Okay, you're all getting it. So now what I want you to do is I want you to look at this next question. It says, to save for retirement, Rocio deposits $400 each month into an account using 7% interest compounded monthly for 25 years. How much will Rocio have saved for her retirement? So that's just an annuity problem, right? Regular old annuity problem. Or Rocio could make a single deposit into an account earning 7% interest compounded monthly for 25 years. How much would her lump sum deposit need to be? So do you see how that's a different question? Okay, so if you're doing your lump sum deposit, then it's not an annuity, right? It's going to go back to that compound formula if you're not using the TVM solver. Okay, so I want you to try part A and the first 2 problems, and then I'm going to come and check on you in your breakout rooms. If you want to do the last one and you're already done, I'll come and check on that too, and then I have more problems for us to practice. Okay, so hold on one sec. Let me get you in your rooms.
I don't know if it's for others as well, but I haven't had the docs come up on my chat. Is that where the problems are that we're going to be doing?
Yeah, did you not just get it? Like I sent the formula sheet.
I just got the formula sheet.
Okay, you didn't get the original doc? Well, that's annoying. Okay, here we go. Here's the doc. There you go.
Thank you.
All right. And now I'm just rearranging you guys a little bit.
Sorry, that was the formula sheet again.
Oh my goodness, what is wrong with me?
I only
Okay,
got the
one-
formula sheet too.
Nice. Well, I'm very good at sending that apparently. Hold on one sec. You know, it's really strange what's been happening in my computer lately. Remember I was telling you my Google Drive was freaking out, and it did just do another update this morning. So, okay, check this one.
Got it.
Okay, good. I'm losing my mind. All right. And then, so try those, and I'll come visit you in your breakout rooms. Make sure you're asking for help if you need it, okay? So I can come around and help you. Hey, Olivia and Amanda, how far did you get?
I think we attempted to do that problem. I don't know if we got the right answers or not.
Nice. That's a hard problem. It's a very thinking problem, but it's
Yeah.
a good one. So, and we're going to go over it in just a sec.
Okay, cool.
Good. And we had gone over all the other ones with you two, right? Okay, good. That's what I thought. Hello. So Yesenia and Valerie, I'm not sure. I checked with you and Angelina and Ashley. I'm not sure we went over all the problems here. So this one, I think I went over with every group where it was to say for retirement, Rocio deposits $400 each month. And then alternatively, she could make it a lump sum deposit. So here's the idea here. Here's what we're trying to show you is most of us don't have $56,000 laying around our house that we can put in a bank account at one time. But we may be able to swing it in our budget to put $400 in each month. Do you see that? And then we would still end up with the same amount of money in retirement. Okay, that's the idea. Now notice on this slide, I have the TVM solvers and I have the formulas for each of them. So regardless of which one you're using, if you get stuck when you're doing your homework, you should be able to pull up the slides and look at what you might be plugging in incorrectly, okay? So, and then on the other one with Lucille, did you get these answers? So again, the same thing. So in 5 years, depositing $500 a month, Lucille was able to save that $33,149.49, where she just deposited $500 each month. But if she had to make one single deposit, she would need $27,000 right then. Probably don't have that laying around, right? Does anybody have $27,000 laying around their house? Yeah, if you do, we probably need to have a conversation because this probably shouldn't be happening. You leaving $27,000 laying around your house. So, or even in your bank account, right? Okay, so any questions on those? Then we went to these poster paper problems and there was really just one problem on there. It looked like this. Yeah. So, and you had to really think for part C and part D for sure. Okay. For part C and part D, you have to think a lot. For part A and part B, you still had to do what we were doing, right? And you had to think it through. So for part A, I got $119,023.28. And I know Aaron got that. So Aaron's group, which was Aaron, Malachi, and AJ. Amanda and Olivia, did you get that dollar amount? Olivia says no. Yesenia and Valerie, did you get that dollar amount?
We did not get there yet.
Oh, okay, you hadn't gotten there yet. But wait, Amanda's changing her mind. Amanda says yes, she did get that. Okay, so and then Angelina and Ashley, did you get that amount?
Yes.
You did. Okay, so what you have to remember when you do this first part, it says, how much will Lucy have in her account at the end of this 30-year period? Remember, it's a two-part thing. First, she does 130 a month for 7 years. Then she just leaves the money. So if you're using the formulas, you have to use the annuity formula and then the compound interest formula. If you're using TVM, you're going to solve for future value, and then you're going to take out your payments and solve for present value, right? Does that sound right? No, solve for future value again. I'm trying to remember. Okay, so then when you do Monica's, she doesn't do anything for the first 7 years. So we don't even care about those 7 years, right? Nothing happens. Then she deposits 130 a month for 23 years. Do you see the difference between how they're investing? So Lucy does it really good for 7 years and then doesn't do anything else. Whereas Monica doesn't do anything for 7 years, but then Monica puts in $130 a month for 23 years. Okay. When you do Monica's amount, you should get $118,973.37. That is just a straight annuity problem. Yeah. It's not a two-part thing. You don't even care about this 7 years. You only care about this 23 years. Does that make sense? All right, now the hard parts of these are part C and part D because they require some thinking on your part. How much money, how much of the amount in Lucy's account is interest? Well, this is how much money she has in her account, but not all of that is interest. So you have to go back and say, how much did Lucy put in the account, right? So Lucy put in $130 a month for 7 years. So to figure out Lucy's investment, or Lucy put in $130 every month. So I'm going to multiply it by 12 and then multiply that by 23 years. Oh no, she doesn't do that for 23 years, does she? Oh, she only does it for 7 years. There we go. Only 7 years. Yes? Better? Okay. Am I still sharing my screen with you, I hope? Okay, just making sure since I had the little problem with my document earlier. So if we multiply 130 times 12 times 7, what do we get for that? Everybody do it on your calculators. Make sure you have it. So 130 times 12 times 7. All right, Angelina, what'd you get for that number?
10,920.
Very nice. 10,000. So that's how much Lucy put in the bank, right? She put in $10,920. So, but look, this is how much she has in her account now. So if we take the amount she has in her account now, and we subtract off how much she put in the account, we will know how much she made in interest. So if you do $119,023.28 minus $10,920, how much did Lucy make in interest? So do that subtraction on your calculators, $119,023.80 minus 10. I think I put the wrong number in my calculator. That's why I just went a little crazy. Minus 10,920. And what do you get for that amount, Ashley?
I'm still working on it.
Okay. All you have to do is subtract those two numbers.
I'm sorry, my dog's freaking out. 108,103.28 cents.
Very nice. So that's how much money in Lucy's account was interest. So Lucy made a lot of money in interest, right? So then you're going to do a similar thing for Monica. Figure out how much Monica put in her account. And then for this last question, you can tell who has more money in their account. We already know it's Lucy, but which account earned more interest? So check that out and see if you can make sense of that. And we'll talk about that answer tomorrow at the start of class. What I want us to do right now is do our exit ticket. So if you want more practice, I have a whole nother worksheet, but I'm pretty sure you have some practice on more that you need to finish by tonight, right? Okay, so here in the slides is an extra worksheet if you want to try it after you do your more homework, right, for extra practice, and the key is there. Don't forget your PF7 is due tonight, right? And you have the PF8 reading due tonight, okay? Your mini lesson will be due tomorrow. Is everybody okay with that? All right, so you can keep working ahead if you want. Please, please, please start thinking about your final presentation, okay? And go ahead and do that exit ticket. And when you're done, you can go. I hope you're reading my emails about your exit ticket if you're getting them wrong, right? Because it's really important that you review those. And if you're not getting emails from me, you must be getting them right. So no worries. All right, have a great Tuesday. Okay, why do I think my answer's wrong again? Is it me? Yeah, I'm getting the same answer that you got, Aaron. So, and Amanda, I don't know what I was doing. So $1,000 each year for 25 years, and it's compounded annually. Yeah, so Aaron, I'm pretty sure you are correct. I don't know what I put in for my key, why it's saying 26. I think it was I think I didn't change my PY and my CY. Yeah, that's what it is. So I'll regrade that. I'll change that. $1,000 each year into an account earning 4% compounded annually. So you should get
Yeah.
41. Go ahead, Aaron.
I was going to say, yeah, when I put in 12 as the PY and CY, it gets out that answer as well.
Yeah, I wonder if I just didn't change that when I typed it in. So you got $41,645.91, right?
Yeah.
Perfect.
Okay, cool.
Good. Yep, so that's right.
All right, cool. Awesome.
Yep.
Have a good day.
Have a good day.
Bye.
I'm confused on my answer that I got.
Yeah, so on yours, let me see. What did you put in for N?
Okay, so I did the formula.
Yeah,
So the formula that I used was the compound interest figuring out A, right?
oh, but it's an annuity formula. So did you use an annuity? Because we deposit $1,000 in every year.
Okay.
Is that what you did wrong?
Yeah.
There you go.
Okay, thank you.
Yep. It is confusing which formula to use and making sure you change everything. All right. Good job.